So today we will look at how to do frequency, recoding, crosstab, and correlation from SPSS. We have the water district data. So first we go to analyze, descriptive statistics, and frequencies. I want to do a frequency of age. I saw from my data view that it's Q34. So I choose Q34. And I look at statistics, I select mean, median, standard deviation, variance, minimum, and maximum. The output window pops up, shows me I have 348 cases, 55 missing. Mean age almost 49. And I have people from 18 to 86. 13 of them refused to answer and 42 find the question not applicable. So these 55 are coded as missing. So next I want to do recoding. You can either go from this data or the output window or the data file. Go to transform, recoding to different variable, Q34, type in the age, new label. You can copy paste that. Click change. So from my previous output, I saw 18 through 39. I want to code those people as young. So that'll be 1. And those people that are older than 40 through 86, I want to code them as old. So that'll be 2. And I want to keep the system missing as system missing. And then click OK. So the SPSS shows the syntax of the recoding operation that we just did. So next we go to the data file. We saw a new variable as cat age. So I want to label the values 1 as young from 18 to 39, 2 as old 40 to 86. So in order to make sure I didn't misplace the former missing values, I want to check. So I do a frequency again of the old variable and cat age, the new variable. Same statistics, click on OK. I saw 55 missing cases and also in the cat age new variable. And I look at the frequency for cat age. Now saw 55 missing cases, so that means everything was done correctly. Next, I'm curious if age, the categorical variable, is related to whether people understand the reasons for water rates increase, which is cat rates. I look at the variable, I saw there are 2 categories, disagree and agree. So that means categorical, I want to do a crosstab to look at the association. So I go to Analyze, Crosstabs, I select cat age as the independent variable, meaning the cause, into the column, and cat rates into the row, and I choose statistics for chi-square. I choose cells. I request row, column, and the total information. So I click OK. Then the output window gives me tables for crosstabs. And in class we discussed we want to pay attention to 2 tables. One is the cross tabulation, and next is chi-square test. So usually when I do the crosstab, I go to the chi-square test table first to see if it's significant. So the sig value is 0.467. That's bigger than 0.05. So usually we want it to be smaller than 0.05. So this means age is not significantly related to people's understanding of water rates increase reasons. Still, I want to look at the descriptive information. So I look at the cross tabulation table, and I saw 61.6% of the young people understand the increase, and 66.1% of the older people understand it. So more older folks understand the reason for water rates increase. And the difference is 4.5, but the difference is not significant. So that means it doesn't matter whether you're younger or you're older. People's understanding of water rates increase is about the same. So that's what I tell my client. Then next, I'm curious because my client says, well, does age influence how much money people make? So I look at the data file. I saw age as a continuous variable from 18 to 86 years old, and income in dollars, so that's also a continuous variable. In order to find out if they're related, I need to do correlation because they're both continuous variables. So I go to correlate, bivariate, and I select Q34, which is age, and income, that's Q35. And the default setting requests Pearson coefficient, so we want to keep that. The other two are for categorical correlations, so we want to just do the default. And the test of significance has two-tailed or one-tailed. So one-tailed means that you know whether it's a positive or negative relationship, meaning that you know the direction of the relationship. Two-tailed means you don't know, you just want to explore. So since in this case we don't know, we just want to keep it as two-tailed. So we click OK. And I have a correlations table. How old are you, age, and income. Remember we said the table, the first column is how old are you and how old are you. So the diagonal is always relating to itself. That's why it's always the correlation is 1. And these two cells, income with age, they're repetition. So they're the same information. I'll look at the table. I first look at the sig value. Again, it's 0.112. That means 88.8% of the time, the relationship is significant. So we want it to be 95. So it's smaller, it's bigger than 0.05. That means the relationship is not significant. But the relationship is negative. So the coefficient is negative 0.114. It means the older you are, the less money you make. However, only 88.8% of the time, that's true. So it's not significant, even though it does tell us a little bit about the relationship between money and age. So older you are, you tell your client, older you are, less money you make. However, only 88% of the time that's true. So with that, we conclude our correlation analysis. So today we have done frequency, recoding, crosstab, and correlation. If you have further questions about this analysis, let me know. You can visit me during my office hours or just ask me during class time. Okay.